The future of steel has great promise. What are the new products? What innovations and applications await? Stay with us and find out. Welcome again to Lakeshore Focus, a weekly show highlighting the key issues, important events, and interesting people in our region. I'm Keith Kirkpatrick. When we talk about the steel industry, we tend to focus on the here and now issues, unfair trade practices, pricing and cost, environment, and workforce needs. What about the future? Will steel be around? And if so, what uses will it have? What products will it inhabit? Where will we see it? With us on our show today are two people who know quite a bit about this industry and where it's going. Let me introduce two men, both from ArcelorMittal Global Research and Development. David White, who is the Director of Process Research, and Dr. Jayanth Chintamani, Director of Automotive Product Research. You gave me the great challenge to get your name right. Did I get it right?
You got it right.
Okay, and you like to be called Jay, right?
Jay is fine.
Jay is good. It's much easier, right? So you've been here a while in this region, your whole life?
I have, yes, yeah. Grew up in Hammond, and my father worked for the steel industry. I have two brothers in the steel industry, and I've spent 33 years so far.
So you got steel runs through your veins?
Steel runs through my veins, that's right.
Is that molten steel maybe runs through your veins,
Yeah,
something like that, right?
That's right.
So my guess is you're not originally from here, right?
No, I'm from India originally. Came to the States for doing my graduate programs and got my master's and PhD from IIT in Chicago. And I've been working for the former Inland Steel, the legacy company, which is now part of ArcelorMittal. And I've been in this building for Global R&D Chicago Center for the past 27 years now.
Wow. So you're just one of us now.
Yes,
right?
yes, absolutely.
You're
Right.
well integrated into
Yes.
the community. What's interesting, I've been out to the place you guys work, the Chicago Center, which is where all the research and development is done. That I've heard people describe that as kind of like the United Nations. It's like there's all kinds of people from all over the world that work there.
Absolutely.
Is this true?
It is, yeah. In fact, at one time we had 20 different nationalities that were represented in just the East Chicago Center alone. That's not counting, all our labs around the world. So yeah, we're quite a diverse group.
Now this is a really big lab. Is this the center is really a big place, right?
Yes, yes.
I mean, compared to all the rest of the locations.
It is one of the largest centers, very focused on automotive market segments, catering the automotive market segments, and also the non-automotive market segments.
Now, ArcelorMittal has research centers all over the world, right?
That's right. We have, we're one of the leading steel research organizations in the world, and we have 12 research centers in Europe, North America, South America, about 1,400 scientists and technicians that work in those centers. And our center in East Chicago is the only one in the United States, and we have about 200 people that work there currently.
So a lot of smart people, including the two of you, right?
A lot of smart people, yeah.
I'll say including the two of you.
Yeah.
Smarter than us.
Smarter than you.
Better
right,
than me,
that's
for
right.
sure.
So do you communicate with these other research centers throughout the world and find out kind of what they're doing? Do you share information much?
Yes, quite a bit, because if you look at the market, what it is doing is, they are looking for products which are similar. If you take the auto company, for example, auto companies are global, and just like our company, we are global. And they would like to have similar products, similar characteristics, similar behavior in different parts of the world, because they are building cars in the different parts of the world. And because of that, we do a lot of technical exchanges between the groups in Europe and us, and also other centers in South America. And there is a lot of engagement in terms of while we develop products, new products.
So the research that you do here is transmitted over to car manufacturers in Japan and Korea and every place in the world.
Yeah, wherever we have the manufacturing units, our own manufacturing, where we cater the local markets, regional markets.
Okay. So you learn quite a bit from these other folks as time goes on.
That's right.
Yes.
I was going to say, and likewise on the process side, we're looking to develop solutions for our plants to make them more efficient that can be used at all our plants around the world. So some of our labs have a little bit different expertise maybe in certain areas than we do. So we try to capitalize on that, and we work together to develop these solutions and get them implemented worldwide.
So I'm going to ask you to probably talk a little more globally today about the whole steel industry, because I think people look at it and say, steel used to be used for almost everything. Everything seemed to be made of steel. And as time's gone on, there's other kinds of materials that are being used to replace steel. So my question is, where's the future of steel? I mean, is it growing? Is it changing? What's kind of your prognosis for the future?
I think if you look at steel, steel is, for a common man, steel tends to be very mundane, like ancient or very old. But actually steel has evolved into new technologies, and it has become more of a high-tech material in a way, the way we are processing and the way our customers are demanding, If you look at the industry, let's say automotive market, they are looking to lightweight, and that is where it can we come across quite a bit about our competitors for lightweighting solutions like the aluminum and the carbon fiber. But still, at the end of the day, when you look at the whole holistic application and what it makes to make a certain part to achieve the same amount of, without compromising all the demands that the customers are, have on these applications, and they're demanding from us, it becomes like a lowest cost solution at the end of the day.
So for those who aren't real technical, this is kind of like watching one of those movies where the guy picks up the sword and goes, this is a great sword because it's so light and it can't be broken. And swords are probably made of some form of steel, right?
Yeah.
So that's the fantasy side of this, but it's the same thing. You guys are kind of creating the new swords, right? The lightweight, the invincible kind of product.
That's right. And the trend is to go for higher strength steels and at the same time make them formable. And in the last 10 years, there's just been an explosion of new product development work going on making these new steels. And that's a lot of what in the product research area, what Jayant's people do. Then it's my people's job to figure out how do we manufacture those steels in the plant. Because they have such different qualities, it really creates some challenges in the manufacturing environment.
That's a good distinction between what the two of you do. So you create the product and he has to figure out how to make it, right? So do you get mad at each other?
More or less. No, we work closely together. 'Cause we're in this together.
So you never hear David say, "Are you kidding? We really have to do that"? You never hear him say that?
No. I think it's a group. It's a team effort. Actually within ArcelorMittal Global R&D, and within the company, the team approach to problem solving is at the forefront.
Well, let me ask you this, because I think a lot of people just assume that aluminum has come and been used for a lot of things, and because it was light.
Yeah.
How does steel today compete, the new steels that you're working with and the new products, compete with aluminum?
I think there are quite a bit of challenges. In fact, there are lots of examples where actually, the customers have reverted back to steel. They have gone and tried the materials that you mentioned, like aluminum, and they have reverted back to steel because of the advantages and the cost effectiveness of the solution. And also the other thing, one other thing that we also touch upon when applications for steel is also to looking at the holistic recyclability of the material and what it really takes, holistically from the birth to the death of the material, let us say, in terms of, we call it as a life cycle analysis, and how does it impact the environment,
So has steel got lighter? Has steel got lighter in weight?
Lighter in weight, actually the applications are getting lighter.
Okay.
It's gotten stronger, which allows you to use less of it for the same applications.
That's a good explanation.
Yeah.
Okay. I mean, because I think a lot of people think, oh, steel's heavy, so you can't really use it if you want to try to do something light, but it is getting stronger. How much?
Yes.
Give me a comparison. How much stronger is steel? I mean, it's just for the lay person watching this show. 5 times as strong as it used to be?
Yeah, if you look at go back in the 80s, okay, if you look at how strong the material was in a car, I would say like, let's say give some numbers here to make so that it is palatable, easily. Let's say about 270 megapascals of the strength of the material. So we used to have like, 45% of the car used to be made out of this low strength steel. Okay, when I say low, 270 is low. And the higher end today, we are going all the way up to 2,000 megapascals, almost 10 times.
Wow.
Okay.
Yeah.
So that's the,
So what kind of problems does this create for you trying to make it then? What's the new challenges from the old ways to the new ways?
Well, of course, when we make these high-strength steels, there's different chemical makeup, which makes it difficult from the steel-making standpoint in order to cast it and to roll it. And then there's a host of other issues that happen downstream when we put it into our finishing lines where we're heat treating it. You've got to weld this material together because we have continuous lines, right? So you're taking a strip of steel and welding one strip to the next. So there's problems with welding that we have to figure out new ways to weld it. There's problems with, challenges with heat treating it.
There you go.
We have to figure out new ways to heat treat it and to cool it rapidly or to reheat it. So it really keeps us on our toes. And I have to say that from my standpoint, I've been in this business for 33 years. This has to be the most exciting time that I've ever seen, just because of these new products that we're developing and the challenges that we have to manufacture them.
Well, that's going to be my next question about some of these new products that the applications are using. But so I get it now. If the steel is stronger and going from 270 to almost 2,000, the simple process of like even cutting, it's got to change dramatically.
Exactly.
And I assume it's a lot harder to bend
Yeah.
than it used to be. So you have to have new processes of how you form it, right?
That's correct. That's correct.
That's got to really keep you on your toes.
Yeah, maybe you want to talk about hot stamping. 'Cause
Yeah,
that's
so
a
what
good-
we have done is, over a period of time, we have gone through several generations of the materials, and that primarily because of auto companies they want to lightweight the products, lightweight their vehicle structure, and as part of lightweighting, then it's working with them and forming them, or maybe they're less malleable. So we have come up with other family of products where we actually hot form it. Okay. So to give an example, let's say at room temperature, the 270 megapascals I was talking about, the way we used to build the cars with, that is a strength level that we're looking at when we're actually forming the material. Maybe twice that.
Do you do that hot stamping as part of ArcelorMittal?
No, we don't. We supply the material, and then our customers actually have their own facilities where they hot form it.
Are they still hot forming, working from coil or slab? Is that?
Coil. Yeah,
Okay, from coil.
Yes. Yeah.
Okay.
Coils we supply the coils, and they make sheets out of that, and they blank it out or cut it out, and whatever is needed to make the part, and they basically heat the part at say approximately 900 degrees Celsius, and then they hot form the sheet in the
900 degrees Celsius.
Yeah.
That sounds like it's really hot.
Yeah, it's
That
quite
is really hot.
Yeah.
So tell me some of the applications that that maybe a lot of the viewers might not. I mean, most people know it's in cars and things, but what are some of the other applications that are fairly different or unusual or kind of future oriented for steel?
Well, Janth has talked a lot about what we do in the automotive industry, which is very futuristic, but we're also making new steels for things like building bridges. Bridges that won't corrode and will have over 100-year lifespan. We're making steel for pipes that transport oil and gas, high-strength steels that won't rupture. We make new steels now for tank cars that you see on the railroad that are hauling liquids that have super high toughness and are puncture resistant. We're making new steels, high-strength steels now for things that will go into something as simple as a guardrail on the highway. but because it's a high-strength steel, it's much better able to absorb the energy of a crash of a vehicle. So it really improves the safety of the highways.
You gave great examples. So in the automotive industry, particularly, I think a lot of people are kind of used to, the skin of the car. It used to be steel, and now a lot of that has changed. But there still is an infrastructure in that car that is a lot of steel, the framing,
Yes,
right?
very much.
And how has that changed?
How is the change? Basically, the emphasis has been on improving safety, basically. So why are they looking for higher strength steel? They want a lightweight. At the same time, they also want to improve safety of the vehicle. So if you look at the safety standards, it has come to a long way. And now we are having vehicles almost basically, we call it as a safety cage, where the passengers are sitting. The key is to make sure that the safety cage is kept intact, no matter where the vehicle is being hit on from which side. It could be on a rollover type of accident, or it could be a frontal, or it could be a side impact. And the key is so a lot of work from our customers, our auto companies, they spend a lot of energy on making sure the safety cage is intact, basically. So that is where a lot of effort is going on, and that is the need for lightweighting and also high strength steel, both, combination of both.
So is steel still used a lot in the aerospace industry? Is there still a lot of use for it there?
There are, landing gears, and there are still steel being used, but in the aero industry, predominantly they are moving towards more of carbon fiber, aluminum, and carbon fiber.
So is that kind of a competitor? Is carbon fiber a competitor to steel?
Yes. For some applications, it is. Yeah.
So what's the difference between the two?
I would say.
Tell me why steel is better.
I would say recyclability. Recyclability is a big thing, and also, like I mentioned before, the amount of environmental impact some of the alternate materials have a very, very negative impact on the environmental. That is our view.
So basically, steel can be recycled.
And of course, cost too. I mean, steel is still a very cost-effective material to use.
So I assume it's quite expensive to produce carbon fiber. That's what you're saying. Yes.
That's my understanding, yes.
Yeah, I know
can't
you're
say
not in that
I'm not a
industry,
carbon
but-
fiber expert, but
Right. Well, you probably at least hear some
Yes.
of that. What are some of the possible future uses of steel? I mean, are there things that people talk about like, hey, we're going to see steel in some different products of the future yet? I mean, do you hear of those kind of things? I mean, years ago, we wouldn't have thought all the steel was going to go into all the computers, I assume, that were made, right? And I assume a lot of steel was used to make all these computers that we have thrown away over the years. I mean, do you see anything in the future? I know at one point we tried to do steel in construction, and it's kind of worked and kind of didn't.
Well, it still does, and we actually have a big effort within our global R&D centers to look at new applications of steel in construction. A number of our labs in Europe are working on that right now. But I think also with the low carbon economy that is coming, we're going to see a lot more uses of steel in things like solar panels and electric cars and wind towers. I mean, we supply steel for wind towers now. But you're going to see a lot of uses for steel in the low carbon economy.
I think for the most part, people don't realize some of the uses because it's kind of buried inside the structure of things, right?
Yeah.
I mean, it's not the glitzy part of the product. Oftentimes, it's kind of the shell or the structure that's there.
Right.
So, do you think that steel these days has a good reputation, or there's been a time we kind of went through that people were kind of pounding on steel and going, this is not a great product. Where are we at with it today? What do you think? I know you're biased, but still, you still have to eat dinner with friends who what do they say about steel?
The steel, I think, like I said, I think it is still a high-tech material. The way it is used, the way it is being viewed, and there are lots of applications that will start. You will see more and more, choice of steel being used, selected as a choice of material for the kind of things we discussed about the strength level, basically like a backbone of the fascia, if you want to call it, I think we think there's a very strong, very positive outlook for steel, from all that respects.
I know one of the things that you're trying to do is recruit young talent into.
That's true.
So
Right.
why should a young person want to really pursue a career in steel, in manufacturing? What's the benefit of doing that? What's been the benefit for you?
Well, first of all, they're especially a job in, I believe, in research and steel research. I mean, they're good jobs. We do a lot of exciting things. As I said before, from a product development and a process improvement standpoint, I think this is the most exciting time that I've ever seen in my 33 years in steel. And I mean, I think there's a lot of good opportunities for someone with an engineering or a science degree to get into the steel industry and to work on some exciting new products of the future.
And also, I think the new applications, I think that's just, the applications, what we feel is that there will be a lot of new ideas that where steel would play a big role. I think that's kind of an exciting thing to go into new areas, and that's one of the I think that will be very good for some of the young engineers.
So
who
you're
would
looking
work
for
on the,
so you're looking for some people who are innovative and kind
Yes,
of got some
exactly.
good ideas.
Yes.
Right.
That talent is real important to you. You guys have won a lot of awards and recognition for what you've been doing. Can you just maybe talk about one of those just real quick and just I'm really proud that we did this?
Okay.
Something you're proud of.
I think one on the in the automotive area, I think one of the technologies that we introduced was to Honda, and this was well recognized, and we were the first steel company, ArcelorMittal was the first steel company to receive such an award for this application on the, we call it as a door ring application. Quite exciting because it involved, because of a global company, nature of the company that we are global, there were global synergies in order to bring this product out to, to the market for the customers.
I think on the process side, I'd look at a new cooling technology that we just recently implemented at our Burns Harbor plant here at the plate mill. It allows us to cool steel plates in a very uniform and controlled manner, and we can get some real metallurgical benefits, some different properties out of the plates. And that was a technology that was developed jointly with our lab in East Chicago and our lab in France. So we're very proud of that.
If there was one thing that you could say to the public, and we're down to probably just our last few seconds here, but one thing you could say to the public about steel that you would really like them to know, this is where you can say something that Kelly will be proud of. So,
yeah, I think when you think about steel, I would like the people to think about safety. The cars are demanding more and more safety requirements, and of course, obviously not because we want to meet the requirement, but more to keep the passengers and the people safe. And steel plays a very big role. It's a backbone of protecting passengers and people.
you need to know how safe it is, okay?
Yeah, and I would say, you see steel everywhere, but it really is a material, we believe, a material of the future. So I would leave that thought, people.
You're both very optimistic about this, and you're very excited about what you do. Does that kind of drive you each day?
Yeah, absolutely. To me, when I look at the young engineers who are working, I have people in the group. We have anywhere from 30 years to almost 65 years in the range, and that's the challenge. To keep them engaged, to keep them work on new things. It really drives.
Well, I appreciate your enthusiasm, the positive nature, and the good image that you've presented of steel, and we're looking forward to you guys being a great partner in this region and Chicagoland area for a long time. So thanks for coming and being on the show.
All right, thank you,
Thank
Keith.
you for inviting us, and appreciate it.
You bet. The positive images associated with steel are quite interesting. We have City of Steel, muscles of coiled steel, steely eyes, nerves of steel, and the man of steel. Even Superman, the most invincible being, was compared to steel. Steel is correlated to terms such as solid, strong, immovable, impenetrable. The steel industry has done well to promote and nurture this image. Even though it has taken a number of negative blows, the steel industry still has staying power. Steel deserves some accolades. It has been an economic sector which has done well by Northwest Indiana, Chicagoland, and this country. Our steel built the incredible war machine that helped pull the world from a horrible war that touched nearly everyone. Our steel constructed cities that reached the sky, creating massive shadows and awe-inspiring canyons. Our steel built cars, trains, planes, and trucks, which moved goods, transported people, took us to work, home, ball games, and parties. Our steel placed washers, dryers, stoves, furnaces, refrigerators, computers, and just about every convenience needed into our homes. For the industrial complex, our steel produced tools, machinery, forklifts, fixtures, shelving, racks, and office furniture. Steel has made an incredible impact in our lives. At some point, steel became a dirty word associated with stagnation, rust, inflexibility, and pollution. We, and I mean we, valued jobs over environment, product over health, pride over safety, and convenience over future. When we woke up, we knew it had to change. I have known the environmental people in the steel industry, and they are conscientious, dedicated warriors who want to help us. I have met the workers who toil inside our mills, and they are highly skilled, hardworking employees who desire to manufacture a quality product. Today you have met some of the smart, talented individuals who strive to innovate, creating new uses and improvements for this valuable resource, steel. I believe that it is important for our nation to produce tangible, usable products. We cannot survive from a full diet of entertainment, technology, tourism, and services. We need a balance. Manufacturing broadens our capabilities, utilizes our talent pool, strengthens our abilities, and helps us understand the total economic picture. Steel is important to us. We need to appreciate what it has done and will do for our region and our future. We appreciate every time you watch us on Lakeshore PBS. Your comments about any of our interviews on Lakeshore Focus are helpful. You can send your thoughts through the website or via email, both listed on your screen right now. If you can't find a previously aired show on our website for some reason, go to YouTube, type Lakeshore Focus plus a guest name or topic, and there it is. Be sure and join us again next week for another Lakeshore Focus. Until then, I'm Keith Kirkpatrick saying, make a positive difference in our world today.